The design process has a certain flow. You start by expanding on the brief, having a huge number of ideas, filtering it down to a few, and then developing one or a combination of those into detail. That's loosely the process, but the emphasis might change. You might start with a lot more information. Typically we get a brief, and that could be anything from a couple of lines to a detailed technical specification. Something like Light.touch.matters, it's almost a completely blank sheet of paper. So there tended to be a lot more of the front end trying to find and define the brief rather than getting into the detail quicker. What's key to industrial designer, the way they operate, is that they bring the human angle in. First thing we do is understand the technical hard points, we call them, the parts that go inside the product, if you like, or the parameters that affect the way it might perform. Then we have to understand the human angle, so we have to see the behaviour of the people that use it. And there's various ways of doing that. You can do it by sort of direct interview, although that's not always perfect because sometimes people cope and modify their behaviour to suit a product, and they don't always do the things they think they do. So we do a lot of observation and kind of covert analysis of their behaviour, and then try and convert that into attributes that make the product better. So having understood the technical parameters and the human parameters, then the first thing we usually do is try and come up with as many ideas as possible. The important thing at that stage is to be very unselective, so no idea is a bad idea, and just get everything down. So there might be hundreds and hundreds of ideas. So we're very unprotective of ideas, no one's precious about them, so people share them. And when you brainstorm and things like that, you create lots of ideas, but it's important that you never criticise or dismiss them at that stage, because everything's got some merit in it. And even the most outlandish ideas, sometimes there's something in them that might be an attribute of the final product. So I always start sketching. Sketching's not just 2D either, it's 3D as well. So it might be with foam or cardboard or anything you've got around you. If you're doing a camera and you've got a toilet roll, some gaffer tape and a box, you might be able to quickly create a model that tells you something about the ergonomics. That's a divergent stage, many ideas as possible. Then at some point you have to stop, eliminate some of them. So you have to take the ones with promise, so it's like an evolutionary process, and whittle out the ones that don't look like they're going to come up with a good design. So you gradually converge then and maybe come up with a number of concepts that you might relate back to the client. So at that point we've sort of converged and we've got the sort of germ of the final idea. But that's not the end of the design process, that's sort of start of another divergent exercise where you explore all the variations of that idea. It might be the overall look of it, it might be the materials, or it might be a technical aspect. And that's when you start sort of developing the idea again. And that's quite divergent. Again, you get to a point where you can sort of agree all those points and then focus. Only then do we really get into detail. So that's when you might use CAD and more accurate model making. So not the sort of cardboard and gaffer tape, but you might use rapid prototyping, 3D printing, machining, whatever it is to make the client something they can get their hands on that gives them an impression of the final product. Usually we do sort of 3 types of model. There's a looks like model, so it might be a non-functional thing that's got the kind of mass and shape and appearance of the final product. And then there's a works like model, which may be fairly rough to look at but gives you the performance of the product. From there on, the detail becomes the sort of specification, so you need to relate that design in the form that a manufacturer can use it. So that might be a CAD model, it might be a rendering, a high quality image, or it might be an engineering drawing. It's usually a combination of all those. And you have to understand the materials at that point, manufacturing processes, and all the other technical aspects. Designers do have a method. It may look to a scientist like a slightly haphazard or a method that relies on chance, but it's not. It's designed so that those chances always happen. It's not entirely serendipitous that you come up with a good design because you've found a way of making those sort of happy accidents happen.